Hi, welcome to the pre-calculus lecture series. And we are in the chapter 5, and this is our lecture number 3 here. We're going to talk about section 5.3. We're going to talk about what is the trig function graphs looks like. And for the previous video, we introduced the trig functions definition and several identities here. Okay, so let's take a look. So what the trig graphs looks like. Okay, so the first thing is here. Okay, well, I thought, okay, so let me share our lecture notes here. Okay, so the first things we're going to talk about is periodic properties of sine and cosine functions here. So for both the sine and the cosine, okay, so they all have a period 2 pi, and we're going to talk about the tangent in the next sections here. So when we talk about the period is 2 pi, what means the period is 2 pi mean? That means after the 2 pi, they're going to repeat the same patterns here. So what's that mean? So that means if you have a sine, all right, t plus 2 pi, that means you turn the whole circle, and then this one will be equal to sine what? Sine t here. And then here, this is cosine t plus 2 pi. This will be equal to what? Cosine t. Okay, so in fact, you can write like you said, sine t plus 2n pi. So it still will be the sine t. That means you can turn many 2 circles, many 2 pi circles. It still will be the same. So the cosine, you can say is t plus 2n pi is going to be the cosine t here. Okay, so that's what is the, okay, so based on that, let's take a look at what is the fundamental, or we call it the parent function of sine and cosine looks like. Okay, so the sines here, right? Okay, so in here, okay, so here means this is a pi, this is a 2 pi, and this is a 3 pi, and the continuous, right? So then this is the pi over 2. This is 3 pi over 2, see here, and this is 1, and this is -1. So if you go to the unit circle, and we talk about, and then you find the special value. So I know the sine function is looks like here, all right, so, okay, so sine functions here, let me be careful here. All right, so it's when the pi over 2 is 1, so here, then go down and go up here. Okay, so this is the one period from 0 to 2 pi. So if you continuous, right? So if you continuous, the function going to continuous like this. So the same way is here, right? If you continuous here, if the same functions here going to repeat, right? So the same function going to repeat the patterns here. All right, so that's why from here to here you see, right? So this one's here, right? So this is the whole pattern of the sine. You get that? So after the 2 pi, the same pattern will repeat. And the few things here we talk about in the sine, the parent function. So when they start here is 0, then pi over 2 is 1, then 3 pi over 2 is a -1, then 2 pi is 0. So after these ones here, then they repeat the same pattern. Okay, so now let's take a look. Okay, so for the cosines here, right? So for the cosines here, so this is a pi, 2 pi, 3 pi. So this is pi, 2 pi, 3 pi. And this is 1, this is -1. So this is pi over 2, 3 pi over 2. All right. So what is a cosine function looks like? Cosine function looks something like this. Okay. Then I go all the way to pi, and go here. And then if you continue, right, so it go down here, then go up here and go here. So here is the same ways here, right? So they continue going up, going down. So like this is the 2 pi period, this is the 2 pi. So this is the initial patterns, right? From the 0 then to 2 pi here. As you can see, after that, then the pattern is repeat. Okay, so we need to remember the key points here. This is 1, and this is -1, and this is 0, and this is 0, and this is positive 1. Just like here we have 3 pi over 1, and the pi is 0 here. All right, so this is the parent function. So remember the key things here. This is the 1, right, at the pi over 2. Okay, so let's take a look. They said, okay, sketch the graph for each functions here. Okay, so the first ones here, let's take a look. So just like we did for our previous ones, right? So when we do the transformation, so this is a pi over 2, this is a pi, this is a 3 pi over 2, this is a 2 pi's here. Okay, so this is a negative pi over 2, this is negative pi. Okay, because so first things here, let's try to graph my parent functions here. So let's say this is 1, this is negative 1, and negative 1 should be a little bit bigger here. Okay, but not okay, whoa, I erased the things here, right? So negative 1 is somewhere here. Okay, so parent function, okay, so cosine, we know the parent function is something like this, right? So you need to kind of, right? So this is my parent function, so something look like this. If the pattern continue, you will go like this. And the pattern continue, you will go like this, right? So this is the parent function. And now in here, I have a transformation. What is this ones here? It's 2. That means I'm moving what? I'm moving up how many? 2, right? So this is 2 and 3. So this point is going to move up to where? Going to move up to here. Okay, move up to 2. Okay, so in here, this one's here, this is the move up to 2. So 0 move up to 2. So basically your x-axis kind of go up to like this also, right? Okay, so now your graph, let's take a look, move up to 2. So when the pi over 2 is 0, so this one going to the 2, move up to 2. Pi is negative 1, see here, move up to 2, so it's here. 3 pi over 2 is here. Then here, this is 1, 2, 3, see here, all right? So that's why my function going to look like this. Right, so that's what is my, if you continue, it will go like this, right? So it's a go up, so it's a kind of go up to, right? Okay, so you get a shift. Okay, so now let's take a look at the next ones here. The next ones here, this is, so you always draw your parent functions here, right? So the parent function is a cosine again. So this is a pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2. This is 1, this is negative 1. Okay, so my parent function of cosine is here, right? Look at those red lines here. Right, so this is my cosine function. If you want to continue, you can do that, or you can just leave that. Okay, so now, this is my parent function. So what is this transformation? You have a negative sign. What that means here. What is that transformation? That is reflecting over what? So this one's here. That means reflect over what? Reflect over x-axis here, right? So this one will go into the positive. Then pi over 2 still will be 0. Pi is -1. I'm going to boom, jump up to the +1. So this is still 0. So what is this one? 1 going to go back to here, right? So now my function here is reflecting, right? So it's going to go like this. Right, so this is my functions here. Okay, so you continue go. And then so here, right? So that's what we call this reflectance here over the x-axis here. Okay, so now we know the reflecting and the shift, right? So how about those, we talk about two very important things, it's the amplitude and the, the period, okay? So if we give any given functions here, right? So for the sine and the cosine curves here. Okay, so the sine and the cosine curve. Now, if right now I do the transformations here, so I have y is equal to the a and the sine kx, all right? And now the y and the y, if I do this a cosine kx here. So the way we define the amplitude will be equal to the absolute value of the a, and the period will be equal to what? Will be, because if we don't have a constant, it's 2 pi's, right? So the period right now will be 2 pi divided by k. So basically, if you take a look at those things here, right? So the amplitude, we use the special term, we call it the amplitude. But, in fact, it's in the transformation, we call it this is what? We call it this is the vertical stretch, right? Or vertical what? Shrink, right? Okay, so it's a stretch or shrink. So how much you have, that's what we, so in the trig function terminology, we call it is the amplitude. That means how high it will go. So like in here, the period is basically, in the transformations, right? We said it is a horizontal. Okay, it's a horizontal stretch, or is a horizontal shrink, right? Okay, so that's how do we define is the amplitude. So what's that means here? So if you have, you can give any functions here, right? So in here, like for example, I have a cosine. If this is the phi and this is negative phi, and if here this is pi, this is 2 pi. Okay, so if I have a sine here, if the sine curve go like this way, okay. Okay, so if the sine curve go like this way, and then it's continue repeat, right? So it's repeat like this. Okay, so for this type of the sine curves here, so you see from here, this red ones here, right? So this is repeat, this is finished one period. So for the period here is pi, that means I shrink, right? Because I have a period of what is 2 pi, right now it's a pi. And then in here, the amplitude here is the from the x-axis to here, the highest point is phi. So that means I did what? I did a vertical stretch by phi, and I did a vertical shrink by what? By 2, right? So that means that I'm pushing like a tighter here. So your y functions here, if you write it, this will be like a 5 sine, and what is the, what is here? So you will say it's a 2x, right? So that's why you shrink it, because supposedly this will be the 2 pi, but this is 2x, so x is pi here. Okay, so that's what we call is the amplitude and the period. Okay, so now let's take a look at these ones here. So let's try to find, they say find the amplitude, right? So find the amplitude for the y equal to the -3 cosine x. Okay, and then let's try to scratch the graph here. Okay, so here, first things here, we know this is multiplied by 3, -3, right? So amplitude is just, this is the vertical stretches, right? So we know the amplitude. So the amplitude will just be what? It will be the absolutely, what do you show is the 3, right? That means the distance from the x-axis to here is 3 here. Okay, so now let's take a look and see we know how to graph these ones here or not. Okay, so this is the pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Okay, so this is negative pi over 2, negative pi. So this is 1, 2, 3, 4. So it's a negative 1, 2, 3, 4. Okay, so now the first things here, you see here, right? So I know, okay, so the first things here, I said, okay, for this ones here, okay, so let's take a look at my first, my first transformation. This is 3, right? That means I need to what? I need to times 3. So let's start with my, my parent function is start here, right? That's what is. Okay, so that's what is my, I always get the negative is a little too small here. Okay, so it's not equally. Okay, so it's -1, -2, -3, -4, something like that. Okay, so this is my parent functions, right? So if you continue, you can get like something continue through the patterns, right? So this one is continuous through the patterns here. Okay, now you times 3. So, okay, be careful, right? So now I times 3 here. So 1 times 3 going to 3, right? Okay, so this is a pi over 2 is 0. You times 3. What is there? Still is 3. Okay, this one's here is -1 times 3 is what? It's -3, right? So this one is what? Still is 0. Pi over 2 pi is 1. 1 times 3 is 3, right? Okay, so this is, I'm not finished, so I'm still using a dot lines here. So this is my what? This is my times the 3s, right? Okay, now in here, so if you want to continue, you can continue the pattern. Now the next ones here is I see a negative. Do we remember what is that's negative mean? That means is what? Is reflecting over x-axis. So this root point 3, so I'm reflecting over to the -3. Pi over 2 is 0, still is here. This is -3, I'm going to reflect into the +3. So here still is 0, and here is still is -3, right? So now, this is my final, so I can kind of graph it. So this will be my, what here? So this is my cosine functions, right? So this is my cosine function because I don't have anything in front of x. So my period here still is what? Still is 2 pi here, all right? Okay, so now let's take a look at the next examples here. I'm going to find the amplitude and the period for these functions here, okay? Okay, so now the first things here, let's do, okay? Okay, so for here, okay, so let's take a look at this one here, the 4. So what's that means? Okay, so that means it's my amplitude is what? My amplitude is 4, right? So that means that the amplitude is 4. Okay, and then the period, okay, let's take a look at the period. The period is here is 3x. I know the the period for cosine is 2 pi, so it's 2 pi over 3. That means now, so this is 2 pi over 3, right? So this is 3, so this is 3. That means every 2 pi over 3, they should what? They should, they will repeat, all right? So, okay, so here is how do we do the graphs here. Okay, so let's take a look here, okay? So this is my, okay, so this is 1, 2, 3, 4, because my amplitude is 4, right? 3, 4. Okay, so now the way we do it, right? So because every 2 pi over 3, I'm going to repeat, right? So 2 pi over 3, so it's, so if you graph here, okay, so this is, so pi over 2, pi, 3 pi over 2, and the 2 pi's, right? Okay, 2 pi over 3 will be where? The 2 pi over 3 going to be somewhere here, right? So I better get a bigger scale. Okay, so let's get a bigger scale so we can graph it better. Okay. All right, so here this is zeros, right? Okay, so let's first start with pi over 6. After pi over 6, so this is pi over 3. And after pi over 3, we have a pi over 2, okay? So then the next one here is 3 pi over 2. Then the next one here is a pi here, right? So I know every 2 pi over 3, I'm going to repeat. That means my period is here, okay? So this is my period. So I know from my cosine graph, we always divide it into 4 intervals here, right? So this is 2 pi, so this is a pi over 2 pi. So I'm going to divide it into a 4 interval. So first I divide it into half. 3 pi, 2 pi over 3, 2 pi over 3, this is a 2 pi over 3, I'm sorry. So 2 pi over 3 divided by half is a pi over 3. So this is a pi over 3, this is the first half. Then the first pi over 3 divided by half is what? Pi over 3 divided by half is pi over 6 here, okay? So now the next one here is 2 pi over 3 and pi over 3. So what is the half here? The half here is pi over 2 here. So now I can graph my cosine function. So we start at what? Started at the 4, right? 1, 2, 3, 4. Then going down for the first quarter. So first quarter, then continue down to the here, continue to the -4, then continue, go up here, then go up here. Okay, so that's what is the graphs here. So every time you need to just increase the pi over 6 as the, the each intervals here. All right, so that's how do we graph it. So the period is 2 pi over 3, right? So then each quarter, because we know the cosine and the sine, they divided into 4 portions, right? So each quarter will be 2 pi over 3 divided by what? Divided by each quarters, right? So 1/4, so it's a pi over 6. So that means for each one here, this is a pi over 6, and here, this is a pi over 6. That's what happens here. Okay, so now let's take a look at part B here. The part B is negative sine -2. So I know my amplitude. This will be equal to the absolute value of 2. So it's 2 here. Then the period here, right? So we know the 1/2 of x is equal to what is 2 pi, right? So the period for x is what is 2 pi times 2. So what is here is 4 pi. Okay, because it's 4 pi, so each quarter is how many? So each quarter will be the 4 pi divided by 4, so it's pi here. All right. Okay, so now let's try to do my sines here. Okay, so in here, let's be careful here. So 2, so my amplitude will be 2 here. Okay, now because each quarter I'm going to divide by is pi's, right? So I started with this is a pi. So this is a 2 pi, 3 pi, 4 pi here, right? So then this is negative pi. So I know the sine graph, right? So this is the parent function of the sine graph. So the first one is zeros, right? So you're going up to the first quarter here. So this is the first quarter, second quarter, third quarter, and the fourth quarter, right? So then you go from 0, the amplitude is what? Is 2, right? So you go up to the 2, then you go down here, then you go down to the 2, you go to here, right? But I do this once here, so I take care of the period amplitude, but I did not take care of this negative sign yet. So what is this negative sign? This negative sign we did it many times. This is reflecting over the what? X-axis, right? Okay, so here the 0, 0 is still here. Negative 2 go boom, going to reflect over to here. 0 still here. Negative 2 go to boom, reflecting to the positive 2. Then the 4 pi is still here. So my final function will go like this. All right, that's what is done. This graph by using the transformations, right? So it's very similar like the one we did before. It's just vertical and horizontal, like the stretch, or it's a horizontal shrink, or some people call compress, right? Okay, so now the next things here we're going to talk about is a horizontal shift. And, so this is the one we talked before, is like when we did other graphs here, we say it's shift to the right or shift to the left, right? So for the given functions here, let's take a look here. So for the given function, okay, so if y is equal to the a sine k x minus b, and or if you said y equal to the a cosine k x minus b, so it's the same here. So in here we assume k greater than 0. Okay, so for here, okay, so this a in front of it, this is what? This is, we call this vertical stretch or shrink, right? So amplitude still is equal to the absolute value of the a. And then this constants here, the k, this is, we call this a horizontal, this we call this a horizontal stretch or horizontal shrink, right? So this number here is determined of what we just did, period, right? So for this here, we have a period. The period is equal to the 2 pi divided by k. Both of them are the same. And then because here, the last one here, this is minus b here, right? So we talked about in the previous transformation. So minus b, what that mean? That means shift what? Shift to the right b units. Right? So if you have x plus b, that means what? You shift to the where? Shift to the what? Left b units, right? So how do we, because right now we involve the period, the shift, and the amplitudes here, right? So we know the period right now is shrink to 2 pi over k or stretch to 2 pi over k. So now we say an appropriate interval on which the graph complete the one circle, one period here. Yes. Okay, so that's why your Okay, so your intervals start at the B. We assume shift to the right, and the then is going to end at the B plus the period is 2 pi over k, right? So it's B plus 2 pi over k here. Okay, so we already talked about the vertical and the horizontal shrink and the stretch. So let's take a look at this, this shift here, right? So let's take a look at these numbers here. So I said find the amplitude, the period, and the horizontal shift, and the graph, the complete with one complete the period. Okay, so this one's here. Okay, so we say, oh, okay, so it's times 3. So 3. So what is this one's here? We said amplitude. So for this problem, the amplitude will be what? Will be 3. That means it's going to go up. The total height will be 3. Oh, okay, I see these numbers here too. So what is that? That is the related to the period, right? So I know the period going to be equal to what? 2 pi over what? Over 2. So period is pi. Okay, so the next thing here is this one here is minus pi over 4. So we say, oh, okay, this is a shift, right? So this is a shift. Because here is negative, so we shift to the right. How many units? Pi over 4 here. Okay, so now let's start the graph here, all right? Okay, so let's start a graph. Okay, so because right now, my new period is pi, right? So I know the cosine, no, this is a sine. So I know the sine have a 4 part. So we know each quarter of the graph will be what? Is pi over 4. That means every quarter is pi over 4. Okay, so now let's start here. So let's say this is pi over 4. So pi over 4 plus pi over 4. So it's pi over 2, right? Then the next one plus pi over 4. So it's 3 pi over 4. Then next one here is what? Is pi. Okay. So then this is the 5 pi over 4 here, okay? So you can continue like this. And because of the amplitude is 3, so we say 1, 2, 3. So it's 3, here it's 1, 2, 3. So it's negative 3. Okay, so now let's try to graph it because we say each quarter is pi over 4. So we kind of, we want to divide this ones here, okay? Okay, so now let's start here. Okay, so we always do it here, right? So first things here, we say this ones here is a shift to the pi over 4, right? So that means I'm shifting here. And the sign, if I were you, I would just do a cheat sheet, say, hey, sine is this type of the graph, right? So each one have a quarter of the graph here. Okay, so now I say, okay, I starting off the pi over 4. So that means that I need to starting at this point, right? This is the equivalent to this point. Then because it's pi over 4, each quarter is a pi over 4. And so my graph is going to run up to here, then go down here, then go down here, and go up here, right? Okay, so this is what is my graph going to look like. So this is the sine graph. Right. Okay, so that means I start with a pi over 4, right? So just like the formula, I starting at the B, so it's a pi over 4. Then ending at what? Pi over 4 plus whatever my period is a pi. So start pi over 4, end at 5 pi over 4. So here. Okay, now let's take a look at the part B here, right? Okay, for the number 5 here, okay? So number 5 here, the first thing here you say, okay, so the first thing is you say, okay, and hey, I see this number 3/4. So, well, that is easy. So that means what? My amplitude is equal to the 3/4. All right, so be careful, inside the cosines here, this is a 2x plus 2 pi over 3. So we need to change into the form we talk about. So here, let me try to write here. This is cosine 2x plus 2 pi over 3. So I need to have x plus or minus something, right? So I can factor the 2 out. So then this is x plus. Okay, so if you factor the 2 out, so what is here? What is here? This is what? This is the pi what? Pi over 3, right? So this is pi over 3. Okay, so now I can change this is 3/4 cosine, and this is 2x plus pi over 3. Okay, so now I can do here. I say, okay, so here this number determined the period, right? Okay, so I can say, okay, so I can say the period here. Okay, so the period will be equal to what? Will be equal to 2 pi divided by 2. So it's what? It's equal to pi here, right? So it's equal to pi. If equal to pi, then each quarter going to go what? Each quarter is going to be what? Pi over 4 here, right? Right, so each quarter going to go pi over 4. And then here, this is x plus pi over 3. So what type of the shift I'm going to have here? So I'm going to have a shift to what? Shift to left, right? So shift to left, how many units? Pi over 3, all right? So now let's start here. So this one's here. So here's the keys, right? So when you have a function, so this is, be careful, you need to, let the x's just be x plus or minus something. So that's why if you have the things mixed here, you need to factor whatever in front of the x out to determine the period. All right. Okay, so now let's try to graph here. Okay, so make sure you get yourself a cheat sheets, right? So this is what is the cosine looks like. Okay, so the amplitude is 3/4. So that means this is 3/4. This is negative 3/4, right? That's what the 1 is here. Okay, because the shift to the left, pi over 3 is here, right? So I would say this is negative pi over 3. Okay, negative pi over 3. Okay, so I'm starting at here, right? So let's take a look at what is my point here. This point here, pi over 3 is here. All right, now I'm going down. So how much I'm going down here is a pi over what? Pi over 4 here, right? So that means each one I'm going to increase pi over 4. So where is the next point I'm going down here? So will be the negative pi over 3 plus pi over 4. So what is this one we give you? It's to give you negative pi over 12. Okay, so that means I'm going down in here. All right, so this point's here, right? So this will be the negative pi over what? 12 here, right? So we are doing this graph. This one's here, so this one going down like this. Right, let me get a curve instead of line. All right, so here, so this is going like this. Okay, now the next one's here, it will be you add another, you add another, the pi over 4, right? Okay, so let's see what do we have and add another pi over 4. So now it's negative pi over 12 plus pi over 4. So what do we have here? We have 12, this is negative 1 plus what, 3. So I'm going to have a pi here. So it's a pi over what? Pi over 6 here. So, right? So I'm going to here. Okay, so this one's here is a pi over 6 here, right? So this is pi over 6. So I'm going to do is this this part, right? So it's the next quarter. So that means my graph going to go what? Continue going to where? Going down to the, go here, right? Stop at the pi over 6. Okay, so now I'm going up, right? Okay, I'm going up. So that will be pi over 6 plus pi over 4. So what do we have here? We have a 5 pi over what? 12 is here. Okay, so that's what you do here. So you say, hey, I'm going to here. This is a 5 pi over 12, right? That means your graph going up here. Now the last ones here, is a 5 pi over 12, you plus pi over 4 here. So what is that one here? Okay, so this is a 5 plus 3 pi over 12, right? So 8 pi over 12. 8 pi over 12, so it will be 2 pi over 3, all right? So it's 2 pi over 3. So that means in here, this one's here going to be 2 pi over 3. So that's why you do the last bridge here. Okay, so that is what your cosine functions here. So, when you do that, okay, so be very careful, right? You need to find out, after you find your period, right? You need to find out how much is each quarter, where you start, right? So I know this one period is start with, so start where? Start is negative pi over 3, end at where? 2 pi over what? 2 pi over 3 here. So make sure, because the sine cosine have 4 parts, you divide by 4. So you know each one, how much. Then you start your point, you continue adding how much for each quarters here, right? Till you reach the one period. Then after you do that, and then the remaining graph just repeat, right? Because after the period, then the graph will be the same, all right? All right, that's it. So this one's here. So for this video, we covered how to do the trig graphs. We focus on the sine and the cosines, right? So the few things we need to be careful is the amplitude. Amplitude is equivalent to when we do the regular functions. That is, what is the vertical stretch or shrink. Then the period. The period we know in general, sine cosine, the period is 2 pi. So if you times a constant, so that will be, we did it before, it's called a horizontal shrink or stretch, or some people call compress. Then we also have a shift to the right, shift to the left, right? Then up, down shift is pretty simple. It's just you add a constants here, right? So it's back to what we learned before. We just applied that into the trig functions. Okay, that's it. And then our next video, we're going to take a look at our functions about the tangent and the cotangent function to see, are they any different than the sine and the cosine function we are just talk about here. All right, that's it. And I hope that you enjoyed it. A lot of students like those trig graphs because graphing is always fun, right? All right, that's it. And you guys have a nice day, and look forward to talk to you again for the next graphs when we talk about the tangent and the cotangents here. Okay, bye-bye.